Okay, I think most of you are ready. So let's get to it and let's just kick it off. And I would like to kick off my presentation with a simple question. So on the slide, you can see two pictures. On the left side, we see a very popular hybrid car. On the right side, we can see European Space Agency Ariane 5 rocket. And the question, as you can read it from the slide, what is similar between the two? How are these two things the same? I think it's safe to say both of them are white, or mostly white. They're both vehicles. They're both designed to bring someone or something from place 1 to place B. But it's an interesting commonality between them is that both of them were designed with fuel efficiency in mind. When we talk about fuel efficiency, it's kind of hard to compare them. The Prius uses approximately 4 liters per 100 kilometers. When we talk about rockets, we don't even talk about about liters per kilometers. What we know is that it goes 35,000 kilometers and uses approximately 700 tons of fuel. And the fuel that the rocket is using is much more expensive than the one for the car. So from a perspective of fuel efficiency, the Toyota will win by far. Simple. But here is a twist. When we talk about real efficiency, it's much more than just about burning less. It's about spending your resources with a very clear purpose. We'll be talking about optimizing IT costs today. And from the first look, when people hear about this, they start thinking about how to save money, and they think about it in a way as hybrid cars are saving on fuel. But from the wider perspective, the rocket is more efficient than the car. And when I conclude my today's presentation, I hope that first of all you will agree and that you will want your organization to be more as a rocket and not like a hybrid car. My name is Svetlana Leos. I'm an enterprise sales engineer. I work for Datadog, and I dedicated last almost 3 years of my career working with different companies across Nordics and discussing how observability can help them achieve not only engineering, but also business goals. As I mentioned, I work for Datadog, and for those of you that don't know about Datadog, it's an analytics and monitoring platform that is designed to help companies to improve observability and security of their infrastructure and applications. And I'm mentioning this because it's important to understand this, to also understand why optimizing IT costs is very important for us. Datadog is receiving and analyzing trillions of data points per hour, coming from more than 35,000 customers across the globe. This means that we operate at a very large scale. Datadog platform is hosted across 3 different cloud providers. We're talking about huge Kubernetes clusters, dozens of thousands of nodes. Our infrastructure costs us a lot of money, and we spend quite some time and energy understanding how to optimize those costs. So today I would like to share some of our learnings with you. There are different ways how you can think about cost reduction. But one important point to know is that optimization is much more than just cost reduction. To be successful with cost optimization, you need to concentrate on 3 key things. The first one is about removing unnecessary overhead and waste. In cloud, it became so much easier to just spin up that another virtual machine and potentially forget about it. So of course, you need to concentrate. It's quite like obvious first step. You need to identify resources that are not bringing you value and are costing you money and get rid of them. I will be showing you some of the examples of how Datadog is approaching this, and also how we actually integrated this to become part of our platform. This is a traditional approach of FinOps, but the issues that we commonly see is that companies just stop there. They have a FinOps team that tells the application teams to use less and spend less. So the second key to success is to prioritize effectiveness and efficiency. You need to have a very clear understanding of what is the business goals that you are trying to achieve, and to not lose it out of sight when you introduce any optimizations. You need to make sure that all the engineering efforts are contributing to the main business goal. And the third one, and I would argue maybe even the most important, is building a culture of ownership. You need to make sure that all these principles that we just discussed are part of the mindset of all the people that are developing and maintaining the services. You need to make sure that this is a part of their thinking on their day-to-day work life. So let's break this down and dive into them one by one. We'll start from the first one, removing the unnecessary. Before we can remove things, we need to have some definitions of what actually our goal is. And if you think back to the hybrid cars, the purpose of the car is to allow you to drive around on the road. So something like GPS navigation unit seems to be a very important part of it. I personally cannot imagine driving around without GPS. I would get lost in 5 minutes. But if you think what's interesting, it's an optional unit. Technically, you can get into car and you will drive, and if you know the way, you will get to your destination without GPS. Additional things like air conditioning or music system, these are default features of all the nowadays cars. But they do not contribute towards the goal and the main purpose of getting to the office in the morning. What they're contributing towards is passenger comfort. So manufacturer, when they produce hybrid cars, they need to make sure that they need to keep a balance between the purpose of driving around and of doing it in a comfortable way. And they also need to keep in mind that passengers are different, so they might need different things. There are many things such as panoramic windows, wireless phone chargers, cup holders. All of these are nice things, but again, they don't contribute towards the main purpose. So your systems should be more like a rocket. A rocket has a very clear goal. It needs to bring the payload to space. And when engineers are working on designing the rocket, all the units that are part of the rocket are contributing, and they are very well concentrated on how to achieve that goal. So how can we understand what's non-essential and can be removed? The first thing is to consider tools consolidation. With moving to microservices, decoupling made it so much easier for developers to, it brought many good things because teams became more independent and it helps them to improve developer velocity. However, it also means that teams with these independencies started consulting less often. So when they choose the tools that they will be using, they don't often collaborate on this. And if they look for a new tool to cover some additional piece of functionality, it's very easy to overlook that existing tool set might already provide the functionality. And this leads to having redundant tooling that you are paying for. We are operating in observability, so we have very good examples that also shows that we are not only talking about a cost of licensing, so not only a cost of having multiple tools, but when we talk about observability, because that's what we know about, it's also about operational part of it. Imagine if you are working on incident resolution. You are incident commander, or maybe just an engineer involved, and you need to log into 5 different tools. You need to have access to those tools. You need to know how to work with them. And then you need to stitch together all the telemetry to find the answer and do root cause analysis to fix that incident as fast as possible. But what if you don't have access? What if you don't know how to use the tool? It means that you need to bring on extra people. It also means that you prolong the incident resolution. And this brings a potential negative impact on the business because incident was not resolved in time. It also means that more people, more human resources were used on resolving this incident. So not all the costs are very straight away and obvious. The second thing to work on is to eliminate unused resources. Cloud providers made it extremely easy to provision new resources as we need them. It also means that it became very easy to over-provision your infrastructure or overlook the unused resources. What we note is that most of the developers are quite responsible when it comes to deleting the compute resources when they no longer need them. However, they would often forget about additional services such as gateway or load balancers. One of the reasons is because those services are automatically provisioned with compute resources but are not automatically deleted. So this is one thing that we addressed. Second good example is testing environment and how it can become a financial drain, because customers don't want to be spinning up testing environment as part of the pipeline. You want those pipelines to be efficient, you want to be able to release and deploy fast. However, think about all the time when your developers are writing code but are not testing. Think about the time when they're not working, like night or weekends, public holidays. All of these are also opportunities to use ephemeral testing environment and to save some costs. And another example is when actually services are used, but they just don't bring you the value. An example that we see commonly among different customers is what we call data hoarding. Companies think that they will need the data, so they store it in some blob storage like S3 bucket in AWS. But when you actually analyze this, you understand that the data is not used. And think about data replication. If you replicate those S3 buckets across different regions and availability zones, this is basically a coefficient in front of the price that you are paying for the services that don't bring you value. And the third one is, of course, auto-scaling. And I'm sure that you all know about this. You are either using it already or maybe considering. But one thing we notice that many companies consider auto-scaling as a way to scale infrastructure up when expecting higher demand. But they don't do the same to scale infrastructure down. And this leads to hours, if not days, of over-provisioned and underused environment. So using it to scale it down is very efficient. And in some instances, you are even able to scale down to 0 instances. And this is basically what serverless is, when you are only paying for what you are using. In Datadog, we do annual reports, used aggregated anonymized customer data. One of the reports that we release is State of Serverless. And we can clearly see that more than half of the companies have already adopted serverless technologies across different cloud providers. So this is something definitely to consider. The next key to success is to prioritize effectiveness and efficiency. And if you think again about hybrid cars, you will often see different fuel efficiency claims for different types of driving. This is because manufacturers don't really know if you will be only driving in the city, slow and short distance driving, or if you will frequently go outside of the city as well and maybe even go on a highway. And this essentially means that none of the driving styles is to the highest efficiency because they need to keep the balance. It's different for a rocket. It has a very clear purpose to get to the space, and all the engineers, all the efforts are designed on achieving this goal. They don't need to think about some potential detours. And don't get me wrong, of course, I'm simplifying things here. There are so many different things that can go wrong with the rocket, and engineers need to take care of multiple different scenarios, but I hope you understood the point. The goal is very clear, and it's very easy to measure. It's binary. Mission either is successful or it is not. And of course, when we talk about your IT systems, it's a bit trickier to measure this success, because your services can be up and running, but their performance can be degraded, and we are not meeting the user expectations. So it's very important to get an overview and establish some metrics that would allow us to be on top of this. And a good example of this is service level objectives, or SLOs. And I could spend the rest of the time talking about SLOs, but instead I would like to refer you to our 3-part blog post that is covering how to establish very effective SLOs and best practices on managing them. This is where we cover all the details, but the goal is clear. You want to end up having a clear overview of how your key services are performing against the promises made to your users, against the promises made to customers, or other internal teams that are depending on performance of your services. Having such overview would allow you to always stay on top of things and make sure that you are not optimizing for a wrong reason, that you are not saving money on infrastructure with the cost of having degraded services and customer churn. Having such overview, a clear overview, and we are not only talking about SLOs, we are talking about business metrics, and I often notice that sometimes people think that business metrics are only for business people, but it's also for engineers, because this allows you to be on top of things and always know that if there is a change, you can quickly roll back and do the change back. When you send you need 4 pieces to successfully launch NASA's space shuttle. It's a shuttle itself. Then we have 2 rocket boosters on the sides. And the 4th piece, the orange rusty looking one, it's not another rocket, it's external fuel tank. Why it's not white as the rest of the system, as the rest of the parts? The white paint is used to protect sensitive systems from ultraviolet light. And actually, during first missions, the fuel tank was painted as well. However, after 2 successful missions, engineers did some extra research and understood that fuel tank does not need this extra protection. So what they did, they left it unpainted. This is how it looked before. But then they left it unpainted. And this meant that they could save 272 kilograms of paint, of weight. First of all, to reiterate that here we're talking that first they made sure that mission was successful, and then this could allow them to concentrate on, okay, how we can be more efficient. The mission is effective. How can we be more efficient? And we are obviously not talking about saving money on less than 300 kilos of paint. I'm quite sure that NASA's budget could afford that. We're talking about the minimizing the mass that needs to be pushed against the gravity forces, and that's an entirely different story. There are 2 tools that we are using in Datadog to do similar investigations and trying to become more efficient. And actually one bonus one that I'll also mention, but mostly we're talking about distributed tracing and profiling. If you think about tracing, this is an example of distributed trace. So a request that is made to our ship order endpoint, it shows us how the request is going through our distributed architecture and our microservices. It's color coded, so each of the services have a different color. And the horizontal lines, called spans, they show individual units of works, either a function or a method. And we can clearly see, first of all, which services are involved. And second, we can see where exactly the time is spent. So if you want to optimize how fast we can execute the requests, this is a very powerful tool because it can clearly see, okay, which part is the widest. That's where we'll concentrate our efforts on optimizing. The less time it takes to process a request, the more requests we can process with the same infrastructure. And more happier our customers will be. Everyone likes low latency and quick reactions from the applications. The second tool is Continuous Profiler. And here, even though the visualization is fairly similar because it's also a flame graph, instead of looking at the time-based metrics, like duration of latency, as the tracing shows us, here we are looking how our services are computing resources such as CPU or memory. So again, we can easily see which parts of the code, which line of code, which function or which file in our repositories is responsible for the biggest usage of the resources. So again, we can narrow down and understand what exactly can be optimized, and you can analyze the third-party libraries and your own code. Here we can see two profiles one by one, because you can also compare how the changes that you do are actually performing. So we are actually comparing the previous version to the latest version, and we can easily see, okay, is it green because we introduced some positive changes, or is it red? In this example, we achieved to do both in one go. Datadog is using Continuous Profiler in the majority of the services, if not in all. And it's called Continuous Profiler because we are not just taking profiles from time to time. Our profiler runs in production all the time. So it means that we can see, as our customers are using services, how our services are using the resources. And one of the examples, one of our teams, the metrics intake team, used Continuous Profiler to look for alternatives of the JSON library in Go. They evaluated a few alternatives, and they found a library that is using 60% less CPU and 50% less memory. So they did the switch, and that change alone saved Datadog more than $400,000 per year, which for me it was quite fascinating to read about it. Just replacing one third-party library led to us saving almost $500,000 per year. It's important to understand how individual services are consuming resources, but the bonus point here is that sometimes it's very valuable to understand how services communicate with each other. And another tool that our teams are using is what's called Cloud Network Monitoring, formerly known as Network Performance Monitoring. This tool allows them to see how different containers, services, availability zones communicate with each other on the network level, what are the volumes and quality of the network. And using this tool, we actually discovered that more than 2/3 of the data fetched by our applications was hosted in a different availability zone than the application itself. And those data transfers alone were very expensive. Here, I don't have a very precise number I can share with you, but I know that this cost reduction saved us more than we were spending on hundreds of Kubernetes clusters with databases. So if you go back to how to prioritize effectiveness and efficiency, embracing experimentation is very important. And I already shared an example of how one of the teams was just experimenting with different JSON libraries and ended up saving $400,000. Another experiment that another team was doing, they were playing with ARM64-based nodes, and these small experiments were proven to be very successful, so it grew up to a bigger project. And we now migrated majority of our services to ARM64-based nodes, and this migration saved us millions of dollars. The third key to success is to build a culture of ownership. Otherwise, if without having it integrated in your culture, you will end up with some of these experiments or improvements being done, in the best case, once in a while. If you go back, of course, back to our hybrid cars and rockets, when you buy a car from manufacturer, you will get a warranty. So if your car breaks, something happens, doesn't drive anymore, you can take the car back to manufacturer and most probably you will get it fixed. But what's interesting about this is that they're responsible for the car. They're not responsible for you successfully arriving to your destination. You need to bring the car to them. It's very different with rocket mission. During the mission, all the engineers are sitting in the room. They're closely monitoring everything that is happening, taking samples, analyzing, sending corrections to relevant teams. This is mostly because those engineers are responsible for the entire mission. And it should be the same with your services. The same as developers can no longer just develop the code and throw it over to operations or SREs to figure out how to run it successfully. In the same way, they cannot just leave all the responsibility for the cost to the FinOps team. End-to-end service ownership means that the teams that are developing the services are not only responsible for the performance of the service itself, but also for the cost. In Datadog, if you're using Datadog, you already know that we talk a lot about tags and how tags allow us to correlate and slice and dice data in different ways. It's the same with costs. And one of the very important tags that we use in Datadog is a team tag. So not only service name tag, but also a team tag. This allows us to identify not only which service is responsible for the cost increase, but actually which team is owning the service, and right away to bring it down to the responsible team. So as you can see, of course, we can break down the cost by team, understand which team is driving the biggest cost increase, and then the team can break it down and analyze why exactly this cost increase happened, did we expect additional demand? Have we maybe switched to more expensive EC2 instances? They can break it down, understand what cloud services are driving this cost increase. They can also compare it to the usage data. If we increased the instance type, is it actually used? Or do we have a 2% CPU usage and the demands that we expected didn't happen, we need to roll back? So the teams can analyze and make the adjustments quickly. But it's not enough to make these adjustments or cost analysis once in a while. In Datadog, we don't do it just once per month or every second week or whenever FinOps report comes in. We made it integral part of day-to-day mindset. Right now, we are looking at our software catalog. This is where we can see an overview of all the services. And this is a place where developers, SREs, team leads come to understand what's the performance or reliability of their services. And now, as you can see on top there, the cost is just integrated part of this. I always can see how much my services are costing. It's an example from our demo environment. Of course, I cannot show you our real costs. We spend more than $500 per month in Datadog. But I can see, okay, which service brings the biggest cost increase. As we release new versions, it's easily to catch those cost spikes and address them right away. And as you can imagine, this helps us avoid this compoundment effect. Because if you release new version, it caused the cost spike, but our FinOps team only told us about this 2 weeks after. It's 2 weeks of wasted resources. But in this case, I think the idea is simple. Make it impossible to miss and very easy to act on. The second part of building the culture is being product oriented. Imagine you are an engineer and you just work on the same, I don't know, pieces of the rocket, let's say a sensor, again and again. It can become quite repetitive. You build it day after day. Maybe it gets a bit boring. Sometimes you make mistakes. You're human. We all are. We all make mistakes. It's all right. But when you know that it's part of a space mission, it feels differently. It kind of makes the project and that sensor feel more special. You become more attentive. You take extra care to not make mistakes. And the same is about your services. Moving to microservices architecture made it much easier to get detached. When you work just on one microservice, you might not even know what other services depend on it. How is it actually contributing to the goal of the business? How does my service make customers happy or unhappy? I might not know about this. So clarifying this and making everyone product aware brings this extra responsibility, and this drives the ownership and better quality of the work. And the last one, and I would say it's my favorite, is celebrating wins. I think we all, or most of us, or many of us, like celebrations. It's not a finger-pointing exercise. We want people to be encouraged and celebrated when they do positive change. In Datadog, we have a performance wins Slack channel. And this is where different teams are publishing stories about their cost optimizations or performance wins. So here you can see I had to blur some data, of course, but you can see that a specific service, the AWS cost for the service was decreased by 70%. And engineers also share how exactly they did it, which services were involved. And everyone, like I am part of this channel. Many people are part of this channel. Our co-owners, our CEO and CTO, Oli and Alexi, are part of this channel, and they are celebrating and congratulating people. And I think it makes people feel quite special. Instead of recognize that we did some mistakes in our architecture, we celebrate the improvements that we found. So this is the first function. The second one, that other teams can see examples. They can see inspiration. If my service also works with Mongo backups and similar AWS services, maybe I can do this similar save as well. And then I will post and I'll get celebrated. I'll get the kudos from CTO. I think it feels special. To recap it, there are 3 keys to success, or at least that's the way we in Datadog approach it. First one is, of course, identify the resources that don't bring you value but cost the money and get rid of them. Consider automatic scaling or switching to serverless technologies if you can. Prioritize effectiveness and efficiency and make sure that all the efforts of engineering are contributing to the business goal, and make sure that you are always on top of how the business is performing and that those changes do not negatively affect the resources. Make sure that you are not saving money on infrastructure with the cost of unhappy customers or unhappy users. And third one, and I would argue the most important one, make it a part of your culture. Encourage experimentation. Encourage people to share their wins. You provide developers with different tooling that makes it impossible to miss out on this information. Put the cost data in front of their eyes so they're always aware of how the changes they introduce also affect the cost. That's it for today. Thank you very much for your attention. If you have any questions or if you want to discuss this, please come to our demo booth. We are always happy to chat. If you don't have time and you want individual conversation, book a demo or check out the resources I was mentioning during presentation. Thanks a lot for coming. Have a nice day.